into web development. So we're here to talk about Django. Django is a web development framework. So what is a web development framework? Web development frameworks are a type of software framework. And so software frameworks provide abstractions that offer generic functionality that can be selectively changed by writing additional code. And so what that means in practice is that Django and other web frameworks give you a scaffolding of patterns and additional libraries that have been selected in order to achieve a solid web application. So really, web frameworks offer specialized tools and software design patterns to help you build, test, and deploy web applications. And so we talked a little bit about why you would need frameworks, but this is why you really need a web development framework. Web development is complex, and it uses a ton of different technologies in order to achieve the final goal of a web application. And so you're going to hear a ton of different acronyms. I'm going to try to answer as many and elucidate as many of them as possible here. But at a high level, you need to understand what HTML, CSS, and JavaScript are, how desktop and mobile web browsers work, at least at a high level. You need to know what HTTP is, Hypertext Transfer Protocol. You'll hear TLS and transport layer security. These are really core security concepts. We talked a little bit about compilers, transpilers, linters. These are all core concepts. Web servers, proxies, databases, design patterns. I'm not going to read the whole list, but you can get the gist that there's a lot that goes in here. And you can see a lot of these logos for these various services. How do you put this all together in a way that is cohesive and delivers good software? And so we're going to go into the key concepts of web development. And this is really going to get us set up to understand Django and understand other frameworks like Django. And we're going to cover the client-server model, web development frameworks, TCP, IP, HTTP, a little bit about HTML, CSS, and JavaScript, and then really dive into concepts about data-driven websites that are backed by databases, design patterns like MVC, object-relational mapping, and single-page applications. And so this client-server model is where we're going to start because it really encapsulates the whole life cycle of a web application and what Django is going to be able to provide us in the end. And the internet enables to do what we call this client-server model. And the best way to understand it, I think, is to look at this diagram here. And so this is probably kind of makes sense to you from a high level, but over here on the right, we have a server. In practice, in most places nowadays, the server is probably living in a farm of servers in some internet provider server farm. Back in the day, it might be just a server on your computer, and in practice, you can use even a laptop to provide a server for a website. It might not be able to handle a lot of traffic, but you can expose even a small web application on your computer to the internet. The internet will fill in the gap of what this means in the middle, and then the client is really your browser or your mobile application or desktop application. And so client server is this whole life cycle between a server and a client, usually client making a request to a server and then responding back. And so this is even a more concrete image what we're talking about when we say client server request response. So clients request something from a server, the server responds. There are new tools now that actually allow servers to push to clients, but usually a client has to request first to make a connection. And then there is a way for servers to push data back to the client. But in most cases, the cycle, especially when we're talking about web apps, is requests from the client and responses from the server. And so going back to some of those technologies before, this is kind of how it maps out in practice. A lot of these, when we're talking about front end, it's browsers, HTML, CSS, and JavaScript, all the different JavaScript frameworks and some of the compilers that allow you to what they call transpile JavaScript versions, because browsers have variations of support of these web technologies. And then on the back end, this is really where Django and where we're going to spend most of our time talking today is on the server side. But it's important to remember that even for a server-side framework like Django, it's going to output things that will be rendered on the client. And so this kind of back-end client server model sometimes blurs the area. And really the thing that connects it all is this giant place in the middle called TCP/IP. We're going to explain what that is. And before we even talk about TCP/IP, though, I do want to dig in a little bit more because we're going to about this bifurcation of server-side and client-side frameworks. So server-side or back-end web development frameworks, this is the type of framework that Django is for the most part. Make it easier to write that whole server-side piece. And so that means handling requests coming in and then pulling data out of a database, handling user authentication, and then finally formatting various types of data like HTML, CSS to send it back to the client, as well as handling security requests. And so backend frameworks are going to be mainly focused on the HTTP responses and being able to return that data. And so popular frameworks that are in this type of server-side framework world are Python, Django, Ruby on Rails, Express, which is JavaScript, Laravel, PHP. These are all variations of server-side frameworks. And then client-side frameworks are going to be mainly broken down to two types: JavaScript frameworks and CSS frameworks. We'll talk more about JavaScript and CSS, but at this point, to understand, CSS frameworks are really focused on the design and what the visual look of the application is. And JavaScript frameworks enable what are called single-page applications. And we'll talk about that as well once we understand a little bit more about server applications. And so we'll return to that concept. But these are some of the things you might have heard when we're talking about client-side or front-end frameworks: React, Angular, Vue, or Bootstrap, Foundation, Material, UI. These are all front-end types of frameworks. And so we've talked about the technologies on either end of client-server model. Now we're going to talk about what enables it. And so you probably may see this a lot: TCP/IP. It stands for Transmission Control Protocol and Internet Protocol, IP. That's where you hear your IP address come from. This is a large set of technologies that have been developed over the years that enable really what we think about as the modern internet. And it describes protocols that allow data to be packaged or broken up, packaged in small chunks, give them addresses and the underlying infrastructure to transmit and route that data across the internet, across the world. And is enabling this conversation right now, this presentation. And so TCP is a very big concept, and we're not going to be able to go even just scratch the surface of it. But we will talk just that there's a high level abstraction. You'll hear abstraction over and over. Abstraction means really that that at any given layer, you don't have to really worry about the thing that's below it. And so for the purpose of this presentation, we're going to be mainly looking at application layer, but that's really at the top of the abstraction levels in these various levels of abstraction. So you have application, transport, internet, and link. That really is going from like your computer, what you're looking at right now, all the way down to the device layer, through the internet, however it's going to be communicated, and then back to the computer. And so it's kind of a what's the word, iceberg when it comes to the understanding of TCP/IP. This is just very high level visualization. What we're talking about, again, like you can see, you have two applications and it goes through the various layers. You can see Ethernet, fiber, satellite, Ethernet, back up through the device, transport all the way back up to your application layer. And in practice, you'll hear something called domain name services, routers. That's all referring to kind of like if you have a host here and a host here, it's going to go through this network topology to get to the other side. And so in practice, for most of you in your day-to-day, you probably are interacting with HTTP directly by entering a URL into your browser window. You probably hear URL all the time and don't actually know what it stands for. So we'll just spell it out here: Uniform Resource Locator. And this is one of the various protocols that's really enabled by TCP/IP. And this is the beginning of kicking off a request for most web pages. And so you'll enter, HTTPS ://dataumbrella.org or something like that. That's the URL, and it's going to kick off the requests. And so what really enables us to get to the point of building a web application is HTTP, and that stands for Hypertext Transfer Protocol. And so this is at the application layer, really allowing the communication between computers or servers and clients, hypertext documents. And you're gonna hear more about hypertext in a moment. But the idea is that when you go to a web page, you are looking at a type of hypertext, which means it's text that has embedded links that allow you to go to other pages. And this is all made possible by the HTTP protocol. And it was first developed by Tim Berners-Lee at CERN, the particle accelerator, in 1989. And we've been using it ever since. And so I've mentioned a little bit about requests and responses. HTTP has a list of what we call request methods. And the best way to really understand request methods is just kind of see the breakdown of them here. HTTP request methods define both how to get data and send data to a server. And so the most common one you'll hear is get. Basically, you're telling the server, I want to get a given resource, whether it's a document or a type of data. You can ask for the head, which is kind of just the top level information about a response, but not necessarily a response body. A post request, which you're actually sending data to the server to be uploaded to a database. And so pretty much anytime you make a post or update a Google Doc, anything like that, you're probably posting some type of data. Or you are using a put, which means actually targeting a particular resource already on the server or in a database and then updating it. Obviously, delete is to delete some data from a server. And then options allow you to support other types of functionality. This isn't an exhaustive list, but these are the main ones that you'll hear about, especially as we dig into Django. And this is an example. So this is what you would see when you enter example.com into your browser. This is actually accessible through your developer tools, and you can see the raw output of the request. But this is what's actually being sent to the server, and the server understands how to respond to it. And so HTTP responses are going to look pretty similar. They have a similar structure with a status line and a couple additional parameters. And so it's easier just to look at it again. And this is what it looks like, that we can see a status, a date, the type of content that it's sending, when the file was last modified. These are all parameters sent by the server. And then when we're talking about the response body, we can see here, and we've heard HTML about 5 times already in this presentation. We still haven't talked about it. But this is the first instance of looking at an HTML response. So when we're talking about hypertext transfer protocol, this is it. This is responding to the request, and it's putting in some hypertext in the body of the response. And so HTTP responses have classes of codes to say whether they've been successful or they failed. This is also not exhaustive, but these are generally types of error codes. 200 is a very common one to say everything is okay for response. And so just to kind of recap here, the HTTP lifecycle, if we look at a GET request, for example, when you put it into the browser, it will go through a domain name server, which is a way for the internet to kind of look up the address that you're requesting, defined by the URL. The browser will make that GET request, and through a TCP/IP will get a response from the server. If the response is successful, it will give us something like a 200 OK response. and then send back the files in small chunks that will all come together to the browser. And then the browser assembles those data packages, and then will, in most cases, we'll talk about HTML, CSS, and JavaScript a little bit more. That's the primary payload, and it will parse and interpret that code and then actually do the job of rendering or painting the picture that you see in your browser. And so this is kind of a more fuller example of what we're talking about when we say HTML, CSS, and JavaScript. This is all three combined. And so in the early days of hypertext and HTML, you might see something like this, where you can see HTML tags. This is CSS code here embedded within a tag. And then we have some JavaScript embedded within the HTML. And this is defining a very simple website that has a title called My Awesome Title. It has a heading, a paragraph, a button in it, and then some logic to both color those different objects or different tags, as well as add some functionality. And what you get at the output is something like this. This is very ugly. And we can see here too that this isn't on the internet. This is actually just on my computer. And when we're talking about server, in this case, my computer is just serving up a single file at this file path. It opens that HTML file with the CSS and JavaScript, and then it renders it. So this is almost like an example without all the TCP/IP stuff. It's just, again, a file serving up some data, and then the browser interpreting it. And then this is just an example of when I click the button, this is JavaScript actually triggering some functionality in the browser, a very simple example. And so we're going to actually talk about HTML at a very high level. We already saw what it looks like, but hypertext markup language is what that HTML stands for. And a markup language is a very declarative type of programming language and documentation system that allows you to define some type of object domain, in this case, a document for a page, in a very declarative way. CSS stands for cascading style sheets, and this is really what allows us to add actual design and style to a given HTML file, and is a similar type of language that's very specific for this use case. It's in the CSS and HTML are not considered like general purpose programming languages. They can't do nearly what you can do with a language like programming or Python. And then JavaScript is actually its own language. So similar to Python, it's a high-level language. It's just-in-time compiled in some cases, depends on the runtime for it. So it's kind of a combination of interpreted and compiled language. It's general purpose. It also can do a lot of the same things that Python can do. And it conforms to what's called the ECMAScript standard, which is a standard that all the browsers, for the most part, will implement in order to enable functionality. And JavaScript really allows us to do a lot of the dynamic things that you will see on the internet. It's really like 97% of websites are using JavaScript. So you can't really get away from JavaScript. Even if you're working on a server-side framework, you're probably going to come across it. And it is also sent over from the back end to the web. And so one other thing about what servers can return, they don't just return HTML, CSS, and JavaScript. They can send over all kinds of other data. These are two examples. JSON, which stands for JavaScript Object Notation, was derived from data structures in JavaScript, but it will return something like this. And then XML, Extensible Markup Language, is another type of language, a markup language that's used to model data. And so servers may just return data like this that can be consumed by web applications as well as other types of services. And so moving forward with HTML, one other thing to point out is that in practice, and this is where web frameworks will start adding structure really to web development, you don't really want your CSS and JavaScript all embedded in your documents. That makes for really large source code files. So you're able to link out. So you can, on the server, I have a file called index.css and a file called index.js, and they can be pulled into separate files and then imported into the HTML. So we don't have to embed it directly. And so we've talked really, really simple websites so far, HTML sites that are just like hard-coded, source code that the server's rendering. But you could imagine if you tried to do this in practice, and what happened if you want to list a large data set, you don't really want to store that in HTML. That would make for tons of repeated tags. In this case, I'm giving an example of just a small table to find in HTML. You can imagine if we wanted 100, 200, 1,000 different names and companies here, this would get really difficult. And that means that every time you wanted to update that list, you would actually have to go into code and change it. And you can't really search that data. It's not very useful. And so, that's where databases and things like SQL, structured query language, come in. They provide ways for us to actually store data in an efficient way that makes it so we can query it and securely access it and distribute it across the internet. And SQL allows us to really work with relational database systems, which we'll talk about more when we dig into Django. There are other database systems, the NoSQL and search engines. But in general, we'll see a lot of SQL and relational database systems for web applications. And so databases offer us a lot of an ability, but how do we incorporate that with our HTML services? So early on, things were developed, or technologies were developed to do what we call hypertext preprocessing. One of the first languages to really do this effectively was PHP. And what that allowed us to do is actually grab some data from a database and dynamically inject that data into an HTML file, and then render that final result in the response. And so this is a kind of contrived example of what maybe an early PHP program would look like, where we're actually, you see some HTML here, and then there's a PHP tag. And now I'm actually writing PHP directly in the HTML file. I'm making a connection to, in this case, a MySQL database. I'm actually writing some embedded SQL right here in line in HTML. I'm making the query, and then I'm rendering a result with the table and dynamically doing this. So this could be 10 entries. This could be 1,000 entries. And it would scale and render whatever is in the database. And so if some other service was updating the database and you reloaded the page, it would give you the most up-to-date code. And so this is obviously a huge improvement on just having a bunch of HTML files sitting on a server somewhere. And so the problem is, if I come back here for 1 second, is this is great, but this is a lot of different types of logic happening right in the code. And it requires me to write SQL in an HTML file in PHP. And you can imagine that beyond a contrived example, this could get really messy over time. And so one pattern that was developed to simplify this and really separate out the logic between both getting data from the server and having a representation that can be used in your programming language is called object-relational mapping. And Django has a built-in object-relational mapper that we'll see simplifies accessing data from the database, where you don't have to write any SQL at all. And you don't really need to know anything about the database. You don't even really need to know what type of database you're talking to. Everything will be accessed through Python, and it will kind of serve as a virtual database that we manipulate and don't have to really think about the database at all. This is another way to abstract the complexity of working with these technologies. And another pattern that we will need to understand is called model view controller. And so what we looked at before, where you had basically an HTML file with embedded code, that was all in one file. What we can do is we can actually separate those different pieces out, the view representation, which is HTML, CSS, the kind of model, which we're talking about object relational mapping, so how the database is modeled and you can communicate it. And then the controller kind of connects the two. The controller is what pulls the data out of the database and then renders in the view. And Django uses a variant, and we'll see slight different language, but it is a type of model view controller design pattern that's used for Django. And so this is just a representation of that kind of abstraction, where you have the model that is kind of representing what your database looks like, and then the controller is engaged by some user request. So like an HTTP request goes through the app, goes through the controller manipulates or queries the database, and then updates will flow through the view, and then the user will see that. It's very high level, but that's kind of what we're talking about when we talk about MVC. And so one final example, and then we're almost ready to dig into Django. I want to give a small example. This is using a framework called Flask, which is really kind of a micro web framework. So it does all the things that we've talked about so far. And Django is a much bigger kind of framework, but I wanted to start with just a really small example of Flask to get a flavor of putting all of these concepts to practice. So in this case, we're using SQL Alchemy. That's our object relational mapper, our ORM. We're also going to be using a template. That render template function is going to give us hypertext transfer or hypertext preprocessing. And then I'm setting up this app. And here we can see we're initializing an instance of an object, in this case, a Flask object. So we're seeing object-oriented programming. I'm defining a database model. Again, I'm using object-oriented programming. And we can see that I'm using a model. So I'm actually extending some of this SQL Alchemy code. And then I'm defining some database columns. In this case, this is an ID and a name. And so we're using object-oriented programming to define a schema for our database, but we're never even having to write any SQL. This is all being abstracted from us. And then we're seeing a function that, in this case, this kind of special syntax above is called a decorator. And what it's saying is that if someone visits the root, whatever web application this is hosted at, that it should return this function's results. And so in this case, you can see I'm using our object relational mapper, our data model, to query all the programming languages that we've defined in that table. And then I'm injecting that variable list of programming languages into a template. And we'll look at the template in a second. But this, just to give you an idea, roughly, although it is, again, in all one file, you can see the separation of both the data model, and then this is kind of the control that's manipulating the database, fetching some data from the data, and then injecting it into a template. And when we talk about templates, template engines are just what enable various languages like PHP, but also Python and JavaScript and other languages, Ruby, to inject data. And so Python has, Flask uses a template engine called Jinja. Django has its own template language that looks very similar called Django template language. And a template looks like this. So kind of similar to the PHP example, but I think a little cleaner, where now the only logic that's here is just logic for rendering the various data. And so you can see this is special syntax where title was passed in as a parameter, and we can render it directly. And similarly, we have our list of programming languages. And this is a similar syntax that we saw before for programming language in programming languages. And then this is rendering out a list item. And what the final result would look like, what's sent to the client, is this. So we can see we don't see any of the logic anymore. All we see is the data that was in the database. And the client doesn't really know what language or pre-processing was done. All it gets is the final result. And so the final thing I want to say before we move on to Django and really get into things and also answer some questions is I had mentioned single page applications before, and you probably will hear a lot about them in the world of web development. Single page applications kind of change the model of what we just saw. So server-side applications will do a lot of the rendering of HTML before the request is made, where single page applications will tend to load all of the CSS, HTML, and JavaScript up front, or a decent amount up front. But it doesn't have to have all of the data. It just has the representation and JavaScript logic. And so what this means in practice is that you kind of render a small bit of HTML and JavaScript and CSS, and then the JavaScript is responsible for loading additional data from the server without a full page request. So that means that your page is kind of staying stationary. You don't see a page refresh, and JavaScript will make a HTTP request for JSON or XML or some other type of data format. It will take that data up into the client, and then it can make updates to the web page through what they call the document object model, which JavaScript has. And so this model is actually becoming more popular, and you'll see more and more frameworks like we talked about, React and Vue, who follow this pattern. Django out of the box doesn't operate like this. So what you'll see in practice is a lot of projects, including a project we'll see a little later that's built with Django, where Django is just used for what's called an application programming interface, which only renders JSON or XML and doesn't really do anything with the HTML itself. And so we're gonna look at Django in its kind of traditional MVC pattern and using views, but it is good to know that a lot of times you'll see more and more of these backend servers responding more to requests just with JSON and data versus handling the entire web page application process. And so before we get into building your first Django application, I do want to give another opportunity for folks to ask any questions that they might have.
Yeah, so there was one question on what is the difference between Flask and Django?
That's a great question. So Flask is very much, when we talk about a micro framework, it gives you just the bare essentials to build what you need. And you have to install a bunch of other libraries in order to really achieve a full-fledged application. So with just Flask, you could build a really simple application, but as soon as you want to do things like authentication or advanced kind of queries, you probably are going to need to install additional dependencies. The other thing that Flask doesn't offer is any kind of structure. So there's some recommended patterns to make with Flask, but it's kind of choose your own adventure. And so when you're building really kind of sturdy production applications, unless you're a very experienced web developer, building Flask from the ground up, you have to make a lot more choices. Where Django is much more opinionated, and it kind of already has the libraries curated in order to build an entire production application. So Django gives you a lot more of the kind of standard practices built into the framework, where Flask is much more plug and play and how you want to use it.
Okay, another question is, can you access a database with Flask, or is Django better for that?
So Flask, like I had showed in that previous example, was using an object-relational mapper called SQL Alchemy in order to access the database. So you can, with Flask, access the database, but actually it's another library that's being used in order to access the database, and you're just installing that using Python. So Flask gives you the ability through other means, where Django has its own object relational mapper. I would say that Django is easier to work with, and we'll see why when we dig into it, where it handles a lot more of the database creation and modeling, where Flask, there is more manual work you have to do. So yeah, I would say that Django, especially when getting started, gives you a lot more tools and patterns for working with the database.
Okay, Nancy is asking, as a beginner, which framework would you recommend I start with?
I think Django is probably a good place to start. And hopefully after this presentation, it will be easier for some of you to jump into it. But if you want to start with even kind of starter framework, Flask is a great place because it does teach some of the basic ideas that we saw in that example that will translate to Django. But I also think that Django is a great place to start. It has really good documentation and a really great community. And it will give you a lot of patterns where if you learn Django and then go to try to do Rails or Laravel or some of these other frameworks, they all have a lot of similar patterns. So Django is a good place to start as an entry point to learn web development.
Yeah, I think that's all for now. If you have any other questions, continue writing on the Q&A section. And people are really liking your slides. If you just joined, Reshma has reshared the link to the slides. You can have it and access it after the talk. Okay, we can now move on to the next part.
So I know we've spent a lot of time not talking